Hey everybody, this is Larry. This is May 6th here in New York City. I'm going to do a random oh, I didn't click on algorithm, so maybe I get a okay, let me try actually get a algo one and not get an SQL one. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and today and all these things. Today we have 333 largest BST subtree. Given a binary tree, find the largest subtree, which is also a binary subtree. Okay. I think the key thing about a binary subtree is that all the subtrees are binary subtrees, right? It's recursively defined, kind of, but with additional criteria. Basically you have the left subtree, you get the max element, so that it can kind of do it that way, right? The max and the min, and if it's good, then it's good, and then you kind of keep it going all the way. So okay, so we just do a recursion here, right? So and maybe I'm a little bit lazy to kind of pass everything up all the way, so we're going to do a non-local situation for me, but you can feel free to do whatever you like. And answer should always be at least one anyway, but that's besides the point. Okay, so then now we will traverse, right? We'll do it in order, but okay, what do we even want to return, right? If node is none, we want to return something maybe, but basically we want to return a tuple that is return min, max, and I guess the number of nodes, right? Because we needed to calculate whatever, right? Okay, so if node is none, then we have an infinity. Then the min is going to be negative infinity. Max is wait, do we want infinity or not? Maybe negative infinity actually, and infinity for the min. And then nodes is 0, right? And then now we have left is equal to traverse, node dot left, right is equal to traverse, node dot right. So is this a binary search tree with this node as the root? Well, it is if left, and we probably should use a name tuple here, right? Let's do that actually. I forget the exact syntax, so let me look it up, because I feel like I always push it off as next time, but why not? I have some time, right? So here this is the basic example. I might not use it, it's just I always forget the exact syntax. So this is the point, right? So then here we have BST data maybe, right? So we have min, max, and count, right? So now we return BST data of this, and I think that should be the correct syntax. I believe I could fly. I believe. Okay, so it doesn't crash, so that's good, because because I think this does a traversal. Okay. So then now we want, so this is not a binary subtree. Oh, well, I have to return whether this is a binary search tree, I suppose. And is BST, right? I mean, I guess this is just now return BST data, and here it is true because just by default it was nothing, right? So if left is BST and right is BST, then we do it. Otherwise, we just return stuff. But I mean, we don't even have to return, because if it's not a BST, then we should just return. I mean, I guess you could check stuff, but I'm just being lazy. I mean, you could return some stuff here for sure, but if it's not a BST, then then this is going to be false anyway, right? So this is all that matters. Okay. Okay, so then now if they're BSTs though, then we have to check that if left.max is greater than or equal to node.value is greater than or equal to right.min, then we're good. Otherwise, again, we just return nothing, right? I guess we don't need an else here. We can just do maybe. Right, so then now we know that this is good, and if this is good, then we can the new total count is going to be, you go to 1 plus left.count plus right.count, right? 1 being the current node. Min is going min is going to be just left.min, right? That's the smallest part of this subtree, and max is going to be right.max, and that's pretty much it. And then we can return BST data of min, max, count, and true. Yeah, yes, but we also have to do one more thing, which is because we said we will do non-local, we'll check, yeah, if answer is equal to max, answer, and count. I think that should be good. I mean, you can, these things I always find a little bit tricky to kind of construct it up. Okay, I returned 6. Why did I return 6? Do I think the 15 is a binary search tree? No, because this should not be, right? Do I? Oh! I messed up one thing, which is that everything is infinity and negative infinity because I don't use the node dot value as part of this stuff, right? So then now, yeah. So then is min of this or no dot value, and max of this and no dot value. This happens when right.max is like negative infinity for some default value or something. There you go. I just forgot to set it. Yeah, and maybe other things. What is the other case? What does this even look like? Oh, I wonder if the duplicate things make it tricky, but I thought there's a thing where they show you the tree. Like, isn't there like a thing? Oh, tree visualizer, there you go. Okay, but now look at this one. Okay, so the answer is going to be 2. Okay, so they want these specifically, which is less than or greater than. I mean, at least this time it is part of the definition, so we can just do it this way, right? But yeah, I mean, not a big deal. It's just how they define it, which actually I don't. I think by default, I want to say that that's not really the but I could be wrong. I don't know anymore. I guess there are variations of the binary search tree, but like I said, easy to fix as long as we kind of look at what they're trying to define here, and that's where also having a good visualization lets you kind of see what this is, because with experience, it's not that I look at this and I know what the issue is, but I know what my code does, right? And yeah, and that's basically the whole thing, is that I know what my code does, and as a result, I don't know why it does 6 though. Actually, it's 1, 2, 3, 4, 5. That's actually concerned. Did it return 6? I don't remember. Maybe I just remembered it wrong. No, it returned 8. So I think that's at least expected. I mean, it's incorrect for this problem, but expected. But anyway, yeah. So as soon as I saw 8, I was like, oh, it's probably just the dupes, and we can handle that easily. At least just to kind of give it a check, right? Yeah, that's pretty much it. This is linear time, linear space, just because that's how stack space works, right? If you could say O of H, where H is the height of a tree, that's fine too. But that is all I have for today. Let me know what you think. Thanks for watching. Hit all the like buttons or the subscribe button. Join me in Discord. If you didn't like this, send it to your enemies and tell them it's good. I'll see y'all later. Take care. Bye bye.